So now you know what SOH CAH TOA means. You can calculate sine, cosine, tan. How do we actually use this to solve a problem? At the basic level of trigonometry, the classic question will generally always start with a right triangle. Application to real life usually may be related to, for example, the side of a building or an object that falls, because it always hits at 90 degrees to the surface of the ground. Maybe you need to figure out, for example, what the distance is for zip lining or something like that. Maybe you need to know how much rope you need. There's the hypotenuse. So if we have a couple of angles, let us call them A and B, and we have our hypotenuse, which we may call C, just to keep it consistent with Pythagoras. The guiding principle is that if you have an equation, you can generally solve it if you have only one unknown. If you have two unknowns, can't do it, because one variable may change at the same time the other changes. Now you have two moving targets. One changes, the other changes, can't nail them both down at the same time. So if, for example, and I'm making this up, supposing we have one side of the triangle is known, maybe the height of the building is 5 meters. Maybe we know that the angle down here is maybe A equals 30 degrees. We want to figure out what the length of C is for the zip line. We know a couple of the angles, wherever we can figure out the third angle. So we could, for example, use, never overlook the obvious, we could use 90 plus 30 plus something has to equal 180, from which we know that this is 60 degrees. How does this help us? SOH CAH TOA. If in doubt, and you're sometimes not sure which way to go, always start by recording the information that you do know. This is a good strategy because it unlocks your mind, stops you from freezing, and oftentimes you'll notice that a pattern starts to emerge. In this case, if we pick the angle, either angle, we could start with, say, A. We know what A is, and if we know the angle, we know its sine and vice versa. So, for example, we know what the sine of 30 is. We know what the opposite side is, yes. And we know what the hypotenuse is. Therefore, we can solve it. In the example of cosine, if we start with the same angle, we know what A is, so we can figure out the cosine of 30 degrees. We don't know what the adjacent side is, so we can't figure out the hypotenuse. Same thing with tangent. That doesn't do us any good either, because you have the opposite over the adjacent. C doesn't enter into tangent. We go back to sine, for example. Once again, we know what the sine of 30 is because we know the angle. That's this one here. We know what the length of the opposite side is to A. That gives us this. Therefore, we can figure out our unknown, which is H. Now we have one unknown. We have two knowns. We can solve it by plugging in sine 30 degrees equals the opposite, which is known to be 5, over our unknown, which is C. We can solve that by rearranging. And then C sine 30 equals 5. Cross multiply. Never forget that this value by itself is simply that number divided by 1. 5 times 1 on one side, C times sine 30 on the other side. To get C by itself, C now equals 5 divided by sine 30 degrees. And as they say in Latin, quadrant demonstrandum.